Okay, here we go. Semi-log plots. Remember, your x-axis is linear and your y-axis is proportional. So, let me find where we left off. All right, we are ready for example 4. And we're going to plot some points. Okay, now remember how this works. I know most of you do, but just in case. So between 10 and 100, okay? See all those divisions in there, and they're not evenly spaced, but the divisions between 10 and 100 are counting by tens. So those labels are 10, 20, 30, 40, 50, all the way to 100. And then what happens when you get to 100, then they start counting by hundreds. So we're on example 4. We're looking at the grid, but we're supposed to be plotting points. Right? So 0 to 100 is going to be plotted where? On the first line above 100, because that's 200. And the one above that's 300. They count by hundreds in there, in that interval. Okay? Go ahead and plot them. Let's compare notes with your partner. Plot them and label them. A, B, C, D, E. Yeah. Your sister took it. I didn't know what to do, and she said she was in your class.
Yeah.
So, okay. All right, compare with your partner. Do yours look like his or hers? Anybody have any issues with plotting? That's good. Good.
0 to 100, so goes up to 100 right here.
Yeah. Yep. In between 100 and 1,000, it's counting by hundreds. So it's 100 and then 200, 300, 400. In between 10 and 100, it's counting by tens. 10, 20, 30, 40. In between 0 or in between 1 and 10, it's counting by ones. Yeah. Okay, proportional. Powers of 10, basically. We okay with that? All right, now we're going to look at example 5. So example 3, which is, we did yesterday, it's got the table over there, example 3. Somebody did a semi-log plot for that data, and there you go, it's right there for us. Write an equation for the linear model of the form. Okay, now, would you agree that that semi-log plot, that's linear, I mean, it looks linear. That means that the actual data is exponential. So we're going to start by writing the linear equation, and then we're going to transform that linear equation into the exponential that actually fits the data points, okay? Now, he gives you a formula there in the box, a y equals formula. That's a lot to remember or to memorize. So I'm hoping that, man, this is when I wish I knew how to use all that technology. So this is 10 to the first. So I want to look at this first point here that's plotted, and it's 1 comma what? 40. So this point right here is 1 comma 40. Would you agree? Okay, but what I need you to understand is that because the number 1 comma 40 isn't really, well, it is in the data, but on this graph, it represents something different because this is a logarithmic plot. So that 40 is actually, that y coordinate is actually the log of 40. So we're going to think of that y coordinate as the log of 40. So my 2 points that I'm going to write my equation for, my linear equation, are going to be 1 comma log 40, and then, I don't know, pick another one. Can we do 2? Yeah, 2 looks like 2 comma log 60. So on the logarithmic plot, or the semi-log plot, we are going to think of our y coordinates as logarithms. Okay, this is a logarithmic plot. We're going to think of our y's as logarithms. So 1 comma log 40, and then 2 comma log 60. Now let's write an equation of a line through those 2 points, because that's linear data. Okay, so what do we need to find? We need to find our slope. So log 60 minus log 40 over 2 minus 1. All right, so let's go ahead and type that in our calculator. Watch your parentheses as you're doing this, by the way. And I got 0.176. Is that okay with everybody? All right, now what? I got my slope. Now, pick a point. So y minus log 40 equals 0.176 times x minus 1. So y equals 0.176x. All right, so I'll figure out what that is. Negative 0.176 plus log 40. I got I got positive 1.426. All right with everybody? So that is the equation of that line. The actual line that you see there. Those points. Now, we have to convert that. We know the actual data is not linear. We know it's exponential. So we're now going to convert this logarithmic linear thing into its exponent form. So again, all this information is in that little formula he gives you, but I'd like you to think about, okay, so what does an exponential look like? Y equals a times b to the x. So basically we have to find a and b. Now remember, where did this equation come from? From a logarithmic plot, right? Those y's are all logarithmic. So now we're going to recognize, okay, here's the slope of the line. The slope of the line corresponds to the b in the equation, but that's a logarithm. So the log of b that number. Alex?
Wait, how did you get from point one? How did you get from that to the log would be? How did you get from point 176?
Okay, we just have to know this. We're changing it back into its exponent form. So we're looking for an exponential, a regular number, basically. We're looking for a regular number. These are all logarithms. Okay? So what I have to remember is, because I can't remember that formula, what I have to remember is that I'm gonna get B from the slope. A is gonna come from the y-intercept.
Could you also just set two equations from the 2 points that we use, like log 40 equals a times b to the first, since we used 1 in log 40?
We could, but again, the directions say use this equation. So we're gonna use that equation, but absolutely you could. Absolutely you could. And in fact, I wouldn't even do that. I would go back to the original data, because the original data is exponential. So if I were gonna do that, I would use whatever those points were, 1 comma 40.
Okay.
Yeah, but I'm trying to use this line to work backwards to the exponential. So how can I find B? If I know this number right here and this number, they're both logarithms. This is the log of my base. How do I find it? Loop-de-loo. So 10 raised to the 0.176 power, basically 1.5. It's 1.4996, so I'm gonna say basically 1.5. And then how do I find, that's my B, how do I find my A? The log of A is that number. So the slope gives you your base, which kind of makes sense because the slope is the rate of change. And the base is what you keep multiplying by to get from term to term, that's your change. So it makes sense that the slope would come, or that the B would come from the slope. Okay, so it looks like that is about 26.669. So my equation is 26.669 times 1.5 to the x. Now we got round off in here, there's no question about it, there's round off all over up here. But let's see how close we came. In the original data, which is an example 3, if we put in a 1, we're supposed to get 40. Well, let's see if we do. 26.669 times 1.5, basically. 40.0035. Pretty close. Obviously, we have round off in there because we did a lot of messing around. But yeah. Let's do another something like this. Turn to where it says check your understanding. Next, check your understanding. And let's take a look at this problem. Did you find it? All right, so here we go. Attendance at the conferences increases over time. Scatter plot shows the year and the log of the number of conference attendees. Okay? So this is, we haven't plotted the actual data point, we've done a logarithmic plot. These y's are logarithms. Okay? Describe how the log of the number of AI attendees has changed over time. Linear, absolutely. That plot, I know there's some jiggling in the beginning, but generally speaking, that's linear. Okay, the logarithmic plot, which is the plot of the logarithms, is linear. Okay, describe how the actual number of attendees has changed over time. Exponential. Because if the semi-log plot, if the logarithmic plot is linear, the data points themselves are exponential. Okay, we didn't graph the actual data points, we graphed the logarithms, we did a semi-log plot. The equation for the line on the plot is given. We didn't have to find it ourselves, they gave it to us. So the equation of the plot is given. Alright. Now my equation's backwards. This right here is the slope, right? So when I write my equation, this is what I'm shooting for. When I write my equation, my base is gonna come from the slope. So the log of the base is 0.0957. So can we figure out our base? Sure. Did you get 1.2465? And then, where are we getting our A, our initial value? Where's that coming from? Right there. So this is, when you write the equation of that line, you guys, you're writing it from a logarithmic plot. These are logarithms. So the log of A is 3.8525. Oh, did you get 7,120? Are you okay with that? Everybody okay with that? Remember, I see the labels over there on the side. See how the first vertical label is 4? What is that really? What does that 4 stand for? 10 to the 4th. Right, so that's 10,000. Remember, those are logarithms. Those are proportional powers of 10. Okay, good job. Let me get your review sheet now. Let's spend a little time reviewing. Got some over here. I actually have 3. We are not going to be able to do all of these in class. We're going to hand them all out today. I could use some help. Gus, would you hand one of those to everybody? Would you hand one of these to everybody? Yeah, including you two, make sure you get them too. So, handing out a bunch of stuff.
Oh, this day's not real.
It's a Monday, man, I swear. Well, like waking up this morning, did not feel good. First day of school.
I had speed school.
Did you really?
Yeah, it wasn't bad. It was 8 a.m.
Clear on that
I
question.
had math practice last week.
At 9 o'clock. George had to go after our basketball game.
Bro, that's that. I wouldn't even go to the CYO game at that point. Kellen's scared me for some reason.
Because Kellen doesn't like you. I think.
I don't think it's necessarily that. I think it's just a matter of.
Okay, let's make sure you get 3 different sheets.
Oh, is the quiz only over 2.7?
Yeah.
Everyone?
Yeah. quiz over the whole unit would be like 5 exams. Okay, so, did everybody get, Kellen, are you about done, honey?
Yeah.
Okay, everybody should have gotten 3 different sheets. They're all kind of called the same thing, but you should have 3 of them. Right? Everybody got 3 different sheets? Perfect.
Yeah.
All right, I don't care. Let's start on the one I handed out, I guess. 2.7 to 215 extra review.
$35.
I'm glad you all know that, counting the minutes. I don't know, somewhere I have a paper, but I don't know where I put it. Oh, there it is. It ends at sheet 35, yeah. You would know. All right, number 1, we're on the one called extra review. Extra review. Number 1, the exponential function is defined like this. Which of the following statements about h is correct? What do you have to look at? What matters in this? What's the determining factor?
If E over pi is over
The base, exactly. I have to look at my base. Now, my base is E over pi. What's E? 2.718. Bingo, 2.718. And pi is, oops, 2.718 over 3.14. So wait a second. That ratio will be less than 1, which means that my exponential is decay. So which statement classifies that? The rate of change. Okay. All right. What do you think? C. The rate of change is negative. Rate of change is the slope. That curve has a negative slope, right? Okay. All right. How about 2? The graph of a piecewise function is shown. Let f be the inverse of this function. And okay, so 2 says find g of negative 2. Okay, so we start right here, right? G is the picture. What is g of negative 2? 1. So this is 1. So now we're going to find g of 1. And g of 1 is negative 1. Is everybody okay with that? Okay. F of negative 4. Now remember, you guys, f and g are inverses, right? So f of negative 4 equals something, which means that g of that something equals negative 4. Well, g of what is negative 4? I think it's 4, isn't it?
yeah.
Isn't it 4? 4?
3.
3?
Okay, 3.
No. So g of what equals negative 4? So in your picture, you need y to be negative 4. Where is y negative 4?
4.
At 4. Right. So when I look at it this way, f of something, that's an x, but in the inverse, that would be a y. So the answer is 4. Are we clear on that? Everybody good on that? All right. The minimum value of f is, why are we saying negative 5? Because that's the minimum x in the original, and the minimum x in the original will be the minimum y in the inverse. Think about flipping the pairs,
Bless you.
right? Does that make
Thank
sense to everybody? Perfect. Next side. Write this as a single logarithm. All right, this is easy. You can do this. So you're going to have log something. All right, so let's start putting it all together. Well, first of all, what do I do with the 3, the 1/2, and the 5? They are exponents. So I'm gonna have x cubed. And I'm gonna have y to the 1/2, but because there's a minus there, that y to the 1/2 will be in the bottom. Another way of writing that would be the square root of y, which is fine. And then what about the z to the 5th? Where is he going? On top. The only way he would go on the bottom is if his coefficient was negative, and it's not. So he's going up on the top. Remember that coefficient's an exponent, right? If exponents are negative, they go to the bottom. Describe the end behavior. You just did this yesterday. So what do you have to look at? 2 things. Just like with an exponent, you have to look at 2 things. What do we have to look at? We have to look at that. And we have to look at that. Now, that's a positive 4. Well, they're always gonna be positive. That's a 4. That's bigger than 1. So that means it's a regular logarithm, which means it looks like this. But because of the coefficient out here, the negative, we're turning it upside down. Is that okay with everybody? So what are we answering? Describe the end behavior. We'll pick up here tomorrow. No, that's mom. Right. Next time I see you, we'll pick up here. Alright, have a great day. Sorry we didn't get to spend more time on this. Hopefully next time I'll have all of the papers turned in. I mean, all the quiz